let me go to the slide mode. Okay. So this is me. I graduated from the State Adelaide in South Australia. I was actually a junior of Puan Razlin. Graduated back in 2014 December, and then when I came back, I was offered by Petronas Gas Berhad as a process engineer. And then on 2018, due to a family matter, I quit Petronas and then I joined just shortly about 6 month time with West Water Technologies and Solutions Berhad as a field service engineer. And then after 6 months, I was offered by ExxonMobil Business Support Center as a process engineer again for a duration of 2 years. And at the end of 2020, I was offered by another company, another American company called Babcock and Wilcox, and that's where I am currently doing right now. I'm as field service and sales engineer. So just to give you a bit of picture here, on the first picture when I was with Petronas Gas Berhad, that was me participating in a turnaround. So that includes like, climbing up like the flares and stuff like that. So that was quite a fun time. So this was in Kerteh, Terengganu. And then I moved to Suez when the Pengerang Refinery Corporation, they were still doing commissioning activities. So I was there basically assisting some of the commissioning activities as a field service engineer. And then on the third picture here, I was basically at the Joliet Refinery in Illinois, USA. I was there for about 3 months for basically get to know about the operation teams and also get to know about the unit operation at site. And that was me because I was deployed alone and nobody was there to help me taking pictures. So I just put up my picture and put a timer on, hence the picture. And the last picture was pretty much like a picture that I took randomly, just because I don't have any picture yet wearing my Babcock and Wilcox coverall, just because for the past 2 years we've been in this pandemic and I haven't been much out to the customer's site doing inspections and stuff. So moving on to the next slide. So this is where I am going to be asking you question. So don't try to like Google it. Just I just want to know, like, I just want to gauge like what sort of understanding do you have about this the keywords that I am showing right now. So anybody can unmute their mic and tell me what do you understand about unit operation? Anybody?
A unit operation is like a system or an operation, like condensate example.
Okay. Good answer. Can I have another one? I mean, you don't have to be. I know when I was as a student, that was pretty scary to be picked on to to answer a question. But let's be chill and just give some of your thoughts about it. There's no right or wrong answer. Can I have another person to give the understanding on what unit operation is? No taker? Okay. All right. So what your friend was saying just now is almost correct. So unit operation is pretty much describing a unit of, let's say, if you are having a physical or chemical reaction or separation. So so if you are in a utilities plant, you are basically converting a raw water into a treated water. That can be considered as a unit operation. Okay, so the next keyword would be plant operations. Can anybody tell me what does that mean to your understanding? Or if there's any chat box, let me see. Is there a chat box, Puan Razlin?
Tak ada dekat chat box.
Run boiler.
Boiler?
Run boiler and cooling tower.
Okay.
And compressor to the system, to the plant.
Okay. Good answer. Okay, go ahead.
Plant operations, more like managing the plant. Control.
Okay, got it. So that's the right answer. So plant operation refers to operating the plant. So we talked about the unit operation when we are converting something into the final product, let's say from raw water treatment into a treated water. And the operation or managing the unit operation as what I've described just now, that is what we describe as plant operation. Okay. Next will be plant operation team. So just unmute your mic and say what a plant operation team would consist of. So I'm gonna start by saying, okay, the first one will be the operators. So can you guys add more to that? So what a plant operation team would consist of?
Process engineer.
Supervisors.
Good answer. Okay, supervisor. What else? Okay,
Maintenance engineer.
Yep. Okay, so you got the idea of what the operation team would consist of. So you would have the most important part is operators, because they are operating the plant at site. And then you have process engineers who are looking into the specific process unit. And then you have the maintenance engineer or maintenance operators, where it would also like be divided into macam machineries or fire equipment or static equipment. And then you have inspection team that do the inspection from time to time. And then you have the HSE, the Health, Safety, and Environment team, and etc. So you get the idea of, as a whole, it's not just, a maintenance engineer. It's not just about maintenance operator. It's not just about operator or process engineer. It's the whole team that's basically managing the operation of your plant. Okay. So, well, unit process is very much the same as what I said just now. I mean, you talk about unit process of from raw water into treated water. So you'll be undergoing a chemical process and also a physical process. So physical process is very much like you are, running through the raw water into activated carbon or a sludge filter. And on the chemical side, when you're doing coagulation and flocculation, like when you're trying to trap the heavies inside the raw water. So that process or that physical aspect of the process is called unit process. One last question. Can anybody tell me what's the most important piece of documentation at plant that all of the employees or all the workers refer to? Can anybody tell me? Oh,
PNID.
Okay, PNID. That's the answer that I'm looking for. So PID is referring to a piping and instrumentation diagram. And this is basically like the Bible, or basically like the most important documentation that I guess all the employees at site refers to when they are trying to do troubleshooting or when they're trying to do maintenance activities and stuff. Somebody said OSHA. So in terms of the safety, yes, OSHA is the guidance that we follow, and that is pretty important and significant. But in this specific situation, I'm asking for if, what is the documentation that everyone is referring to when they want to do specific work. So the answer is PNID. Okay, so before I go into detail of what a process engineer do on a daily basis, I am going to also just cover a little bit about some of the processes that I took care of when I was with Petronas. So this is basically an example of a block flow diagram, BFD. So a block flow diagram consists of pretty much like, what the process would entail. So in this particular picture, in this first particular picture, you get information about what the process, what the unit block of the process is telling you. So there's a raw water treatment. You'll get what is going in this particular example. There's a Hanover County effluent, or I would say any untreated water you feed in, and then what you get out is oil/water, and also filter solids to landfill. So this is just pretty much to give you an idea of what a block flow diagram. I'm sure that you have learned it during Puan Razil's class, but I just want to reiterate back and just give you an example. So this is pretty much the processes I took care of when I was with Petronas. And you can have a very simple block flow diagram, and then you can have a bit of detailed block flow diagram. So on the second picture, you can see it specified a little bit on the row. So here it say effluent, but here it tells you the water is coming from river. There's an intake, pumping, resedimentation, coagulation, flocculation, clarification. So this is also considered as a block flow diagram, as long as you don't see any equipment on it. That's still considered as a block flow diagram. Okay. This is another example of process flow diagram that I took care of when I was with Petronas. So I took care of the boiler treatment. So I talked about the raw water treatment that I treated, and then it will go into a treated water tank, and then the treated water tank would then be fed into this system, which at the end of it, you will get steam, which you will use it for other application on the plant. So this is how a process flow diagram looks like for boiler treatment system. As I mentioned, so there will be a treated water tank. Just imagine it's over here, and then it will be fed into a softener or damming unit, which will further polish the water, and then we'll go through the deaerator, which the function of it is to suppress the dissolved oxygen, just because the boiler can't take a certain dissolved oxygen in it. So you'll have to suppress or like remove the dissolved oxygen in it by using chemical called oxygen scavenger. And then basically you will produce steam, which you heat it up in a boiler at certain pressure and temperature. Any questions so far? Okay, I'll move on. So this is another example of a process flow diagram so the process I took care of when I was with ExxonMobil. The unit I was looking after when I was in ExxonMobil was a delayed coker unit. It's pretty different to the utilities side. So when you guys talk about like refinery from getting the oil from the well, and then it will be treated first at the distillation unit. So the very heaviest material, or the very heaviest ingredient that's coming out from the bottom of the distillation unit called resid would fit into this unit that I was looking after. I'm not going to talk too much about it. Just going to give you a little bit of idea on what a more specific process flow diagram look like. So on here, you can see a big main fractionator. And then you'll have a coke drum over here, and then you have 2 units of So main fractionator feed into furnace, and then the coke will go into the coke drum, and then from the main fractionator, you will also get some products from the light gas, and also heavy gas oil and light gas oil from here, and then the byproduct will be coke that you will get from the coke drum. Not to worry, I took about 3 months to understand the process. So once you started working, it's okay. I mean, when you look at this, there will be ample time for you to understand about the process and stuff like that. Also, just to give you another example of the piping and instrumentation diagram called PNID. Sorry, there's a typo in here. So this PNID, just to give, so when you look at the PNID, what you can see is, of course, the piping information. So you can get to know about the size of it, the rating of it, and also the instrumentation. So all of the instrumentation, like temperature transmitter, here, PI, it's temperature indicator. What else? And also you can see the valves, the size of the valve, the size of the piping. Just to give you an idea, 2-inch right here, it's indicating the piping size. And then 1801051, I forgot about it, but I think the last digit would be telling you the rating of the piping, but I'm not, I can't recall. So just take it with a pinch of salt. So the confirmed information is 2-inch pipe, 2-inch valve here, and then the instrumentation detail. So when I was working in Petronas Gas Berhad, the first thing that you have to do when you're working at site is you have to bring your PNID, go to the site, and then you have to do line tracing. So what you do is you look at, say, for example, if you want to look into this instrumentation, right? There should be a TI here. So you just like do line tracing and then try to find if there's any TI in that said location. And another interesting example on this PNID is who can tell me what this blue and white symbol is? Anybody can answer this? I give you guys 10 ringgit. Right after I finish this.
Water.
Sorry?
Indicator.
Indicator, no. I take another 2 answers. 10 ringgit, I'll transfer to your account right after I finish this.
Water.
Water? Nope.
Temperature.
Temperature. Okay. No. So
Cooling system.
sorry.
Cooling system.
Cooling system. No. Okay. There are probably more questions that I will ask later for that 10 ringgit offer, but for this time around, this is what we call blind. So you can look it up later. It's a blind. So what a blind does is when you have a maintenance activity, let's say in this particular column, this blind is used to isolate the lifeline to the end of the equipment. So say if there's any work that requiring somebody to get into this tank. So this, what we call a spectacle blind, it will be swing and then close the line over here, so that this line will be basically dead end. So no process stream will go into this area. And the process of doing that is called physical isolation. Again, I asked that question because I think I was working for about 6 months until I get to know about this. So that was pretty, if somebody know it, then, you know, I would be totally impressed and shocked. Okay. Moving on. So what does a process engineer do? So this is specifically when I was working at Petronas Gas Berhad. So the role that I was doing was very much took care of the utilities plant. So that include water treatment, steam generation, wastewater treatment. There's also a nitrogen unit and also flare gas recovery unit. I've give you a little bit of brief idea on the block flow diagram and process flow diagram of the water treatment system and steam generation system. So what the process engineer role entails was on daily basis, what you do is you perform daily monitoring on unit operations. As I mentioned, the water treatment. So when you look into a process treatment processes, what you're trying to do is you're trying to treat the raw water to eliminate the heavy metals inside the water. And also you're trying to get the what do you call the organics or inorganics matters that's inside the water that you don't want to be carried over into the steam generation, which will be used to produce steam later. So what you're looking at is basically you have different charts showing, let's say, silica level, right, on daily basis. And you will have certain, what do you call it? Sorry, not indicator, certain level that you have to be working under. So let's say if the silica is, that you're looking at on that particular day is, let's say 5 ppm, but the highest that you can go is 4 ppm, then you're in trouble. So you have to figure out what's causing the silica spike on that day. So that explains the second bullet point, which is perform troubleshooting and root cause analysis investigation. So on that day, if you're seeing there's a spike of silica above the limit that you want, so you have to have your silica be below 4 ppm, but like today you're working with 5, then you have to find out what's actually causing the spike. And then the third bullet point would be advise technical recommendation on the process troubleshooting. So once you figure out, oh, there's actually a root cause for this particular solution. So the silica is coming from the raw water. So the input that you get is pretty much higher than normal. So what you can do is possibly advise the site team to do a frequent polishing at the damming tank, so that you can get the silica below the limit that you want. So this is very much like the first bullet point is very much telling you what a process engineer would do on a daily basis. But at the same time, as a process engineer at site, you will also be participating in a shutdown and turnaround. So during shutdown and turnaround, you would have an equipment to do inspection, or you have a loading of say catalyst or desiccant into your tank. That's where a process engineer would go and inspect. For inspection, so for boiler, you go into a boiler and then see if there's any defect inside it. And once the defect has been repaired, you probably go for a second round and check the quality of the quality of the defect that's being repaired. But it doesn't necessarily mean that you would do it alone. Of course, there will be like a inspection engineer with you, or inspection operators with you. So you'll be the person to actually like give your insight as a process engineer what a good equipment should look like that won't be jeopardizing your process later on when it's online. The third bullet point would be you will also be involved in a commissioning activity. Commissioning activity would include, let's say if you have a new plant at site, or let's say if you have a new equipment installed at site, you'll be the one like checking whether like the equipment is working or not during the performance test run, etc. And then the last one would be to be involved in the management of change. So MOC is very much a process where you get approval. Let's say if you want to change a valve, so from 3-inch to 2-inch, so you would have to start approval process of why you want to change from 3-inch to 2-inch, up until the handover process, up until the installation, PTR, performance test run, and also the handover back to the operation team. So that's pretty much what a process engineer would do in oil and gas or petrochemical facility. I then move on to a role. What does a process engineer do in so I worked in ExxonMobil for 2 years, but remotely. So just want to reiterate, as a remote process engineer, you are sitting here in a building in Kuala Lumpur, looking after a unit process in USA, in America. So you don't have the luxury of like, going to the site, touch the equipment, or visually looking at the equipment face to face. But rather you're just looking into data, into PNID, into the daily data that you pull. So this is pretty much different to what the role that I had with Petronas. But luckily, they sent me over for about 3 months just to be used to the equipment, like going there for 3 months, get to know about the processes and also how it's looked like, and also talk to the operation team over there. And then when I come back to Malaysia, I start doing remote monitoring as a process engineer, where I pull the data. So it's basically you take whatever data that you have from the site, and then you analyze it. Again, same with what I've mentioned with Petronas. You look at the limit, say you're operating above the limit, then you talk to the site engineer or site team and say, oh, this is an outlier, or this is a problem that I'm seeing from my office. Can you do something about it? So that explains the second and third bullet point, which pretty much the same as what I did in Petronas, but the difference is I'm doing it right here in Malaysia. but the plant that I was looking after is basically in the US. At the same time, I also involved in an optimization and improvement case studies and advice technical recommendation to site. So what does this mean is basically, so let's say on a daily basis, the processor or the unit operation that you're looking at is doing good, like there's not much problem that you're looking at. So that's when you try to improve, say, to improve the product. So you want to increase a little bit of product inside your unit operation. So what you try to do is you try to advise the site team to adjust a little bit of parameters, say increase the pressure, decrease the temperature, just to get that much of additional product, which would be translating into a monetary. So let's say if you want to increase contoh C3 propane punya product, let's say on a daily basis you have 25 kiloton per hour, and then when you look on one particular day, there's nothing happening on the problems, and then you look at, oh, there's actually a room that you increase to 26 kiloton per day, and that 1 ton that's translating into monetary, contoh $1,000. That is the optimization and improvement that you can do. The third bullet point will be backfill plant engineer. So when a plant engineer, so basically when I was working as in ExxonMobil, we are working on a Malaysian time. Over there it's night time. So they took the advantage of there's a process engineer at the site during their siang, during their daytime. Our nighttime, of course, we tidur. But on their nighttime, we have somebody in Malaysia like looking at the processes. If there's any problem, we'll be the person who look into it and then tell the shift team over there what to do. So during the site, the plant engineer, when he was going for vacation or he was having sick days, so I will be the person who will be backfill. Backfill meaning basically you do the plant engineer punya role. All right. Moving on, as I mentioned just now, I have moved the role from a process engineer to field service engineer / sales engineer. And what I'm currently doing, my role right now, is basically looking after boiler equipment, coal pulverizers, waste to energy, etc. So Babcock & Wilcox is basically a company known for manufacture boilers. They are the OEM, operation and maintenance, or the original equipment manufacturer. So what I do now is, if there's a customer requiring me to do inspection at their site, say they have problem with their boilers and they want me to look at, and I'll go to their site and then do the inspection and then provide technical report on that. I would hence also provide technical advice, say if there's a defect on it, what as an OEM would do to either like do repair or to replace that. And I also engage with end users and customers to upgrade or replace the equipment. So if the boiler is already like nearly 30 years old, 40 years old, and keeps on making problems, then I'll try to talk to them about like replacing or upgrade the boiler. I am also doing business development in new regions. So basically, I am doing a business development in Malaysia. I am the first Malaysian to be employed in Malaysia by Babcock & Wilcox. So my headquarters is basically still in Akron, Ohio, US. We haven't had any business entity yet in Malaysia, but that is something that I'm working on right now. So basically, what I'm doing right now is basically setting up a business entity, and then once we have that, and then we can engage with many more customers in Malaysia, including Petronas and also TNB, whoever that has boilers to make steam and use for their plant operation. Now, let's talk about the challenges that I face since I graduated with chemical engineering background, and field service engineer with my current company is pretty much mechanical and also reliability centric. So of course the challenge would be lack of mechanical and reliability knowledge. I can't deny that. I am more to the process side, and when I took this job, it took me a little bit of time to understand, the mechanical and the reliability aspect of, when we talk about selecting the material for boilers. I would have some ideas when I was a process engineer, but working as a field service for manufacturer is pretty much like there's a need for you to understand different grades of carbon steel for different types of application of steam. So I was quite struggling with that, but over time, with the right guidance and mentor, definitely it's not an issue for you to like move role. Even if you have a background of mechanical engineer, let's say one day you feel like, oh, process engineer is something that is interesting and you want to do in the future. So I would say it's something that is doable. It's not totally possible. Another challenge that I have is not looking into just one facility and technology. Right now, I am looking into a South Asian Pacific businesses. So basically, before this, when I was with Petronas and also Exxon, I was only taking care of just one facility, like one stagnant facility. But here with Elco and Wilcox, I'll have to frequently travel to customer sites. So I would say it's a challenge because you are requiring a lot of time to travel from one site to another, and your customers or your end users is also different from time to time. So you have to deal differently from one customer to another. And the adaptation that I have from process engineer to field service engineer is basically if you have a significant understanding of processes. So when I talk about at the very beginning, I involved as a process engineer to treat water treatment up until steam generation. And then now I'm working with a boiler manufacturer. That helps quite a lot because you understand what a boiler does from a process engineering point of view. So when you see a customer and then you consult them with a problem of a boiler that is coming from a process site. So for example, boiler can be corroded if there's imbalance of chemical that is used to control the corrosion. So from a process side, you understand that you need to have a really balanced and correct ratio of chemicals that you use. Where I think it's also hard for a mechanical engineer or mechanical background engineer to straight away pinpoint that's a problem. So I think that really helps me in this current role, having that process engineering background before. Working in inter teams helps. So what does this mean is that when we talk about when we talk about the plant operation teams just now at the very beginning of the session, as a process engineer, you'll be working with HSE, you'll be working with maintenance, reliability, civil, maintenance. So you'll be working in a very interrelated teams. So what does this do is that you would get some knowledge from a different team, like how you handle certain things, but also when you are, so with my current role, the end users will be coming from a different background as well. So I'll be talking to a reliability engineer, I'll be talking to a process engineer. So previously that I worked with a different teams before really helps in terms of like, you know, try to convey the message I have, try to convey the data that I have on a certain way. Because it's very different, like, you know, talking to from a process engineer talking to a process engineer and a process engineer talking to a mechanical engineer. That would be requiring a little bit of tweak into what you try to convey to them. So process engineer to process engineer, if you have a lot of like process data, they will love it. But with mechanical engineer, they pretty much like just want to see what's the problem that you have, and then what, from mechanical point of view, what is wrong with it. Just interesting. The last point will be well versed in site documentation. So as I also mentioned during earlier part just now, you'll be working a lot with PNID and also datasheet. Datasheet is where you get, so for a pump or compressor, that's where you get the rating, that's where you get the design, flow rate and stuff like that. And also the mechanical drawings is also another drawings that would help. So it's pretty much like if you have any equipment, that will give you like the dimension in detail about what the equipment entails. And to be able to actually know about this documentation later on when you are working at a different company, still working in let's say petrochemical or oil and gas, that really helps in terms of like understanding the processes, the equipment, etc. So I think that's pretty much the material that I have for today. I would open now the floor if you have any question at all. I think we have 20 minutes. 20 minutes, right, Puan Rizli?
All right, so open to the floor. Anyone with questions? Anything that you want to ask, either about the career path or anything that related to your syllabus or anything, feel free to questions, to have a question, to raise your questions. Or maybe who is a little bit shy can put it in the chat box.
Cakap Melayu pun boleh.
Cakap Melayu pun boleh, don't worry. Saya kena bagi nama ke ni?
Ramai dah lari ni.
Itulah,
Discuss the meeting.
macam mana ni?
Anything at all, like apa je macam pasal second year, pasal interview, stay too early kan.
Okay dah. Tu Dash dah tanya soalan. Okay, go ahead.
Okay, nama saya Dash. Thank you for the briefing time. So, question saya, kalau in case as an engineer, any certificate macam additional yang kita ambil semasa study atau after study, any suggestion for that?
Okay, so definitely you will be having to take the graduate engineer from the BEM because that's mandatory. So that's the one thing that you have to do. So funny story is I just applied for it after working for 8 years. Lepas kena ceramah dengan my IR pakcik, my IR uncle, just because when you're working as an engineer and you don't have that graduate engineer certificate by BEM, basically it's illegal to be practicing engineer in Malaysia. So that's one thing. I think it's the fees is only 50 ringgit if I'm not mistaken. The requirement is just you just need to upload your degree and then get the signature from any IR that you know. Any other certificate would also be graduate technologies. because that's a nice thing to do. But possibly after you're working, well, graduate engineer you can take straight away, and then possibly after that, after you have been working for 3 or 4 years, you can start applying for technologies, TS, and also IR. Most of my friends yang dah kerja for 6 years, 7 years pun dah ada. I mean, it's quite a rare case, but they already have an IR title. So it's just a matter of like applying it and whether you're serious about it or not. Which also translating that I'm not really serious about taking IR because I haven't had IR yet. But other than that, certificate for, let's say if you want to take like OSET ke ataupun CIDB, I think it's usually for fresh graduate, once you have been hired, the company would ask you to do it. So you don't have to use your own money for it. So I would say those two lah yang important. Graduate engineer by BEM and graduate technologies by what's the
MBOT.
The MBOT, yep. Yang lain tu I think macam it depends lah if okay, when we're going into macam later when you graduated and then macam there's some time when you feel like the company nak hire you, then you can start looking into macam certification. Let's say if you want to do inspection, then you can start looking into macam short course or of maybe inspection punya course ataupun safety punya course, depending on what your interest is when you want to join the workforce later. But it's also depending on later lah when you graduated and macam the economic is not that good. So it's really depending on situation lah. But otherwise, I would say just those two certification lah.
Alright, so basically you guys don't worry too much because upon your graduation later on, our university will definitely ask you to register, okay? So nanti awak punya mak-mak PA ke, bapak-bapak dan semua akan panggil awak and then make sure you fill in the form and then submit by university. So itulah kelebihan graduate dekat lokal tau. Kalau kita orang dulu sendirilah, tu yang lepas graduate pun kita orang tak sign up for that. So dah rugilah yang dia kata illegal for a few years tu, and at the same time kalau you nak buat IR, it's not account for. Maksudnya you kena start on you apply graduate tu baru dia start you punya experience. So kalau you nak buat IR, kalau kawan you dah kerja graduate dan bekerja saing dengan your friend, but he or she can apply for the IR 6 or 7 years, you kena tambah lagi sebab you lambat register. So don't worry too much about that sebab you guys memang compulsory untuk apply untuk MBOT tu. Alright, next question. Siapa lagi nak tanya? Siapa malu boleh tanya dekat chat box. The girls, come on. Girls power, tak kalah.
Tadi je soalan, best tak kerja seorang dekat US ke?
I have a question. In diploma, I finished chemical engineering, but in degree, I changed to mechanical. So I'm a bit torn apart to know that if it really advantageous for me to change from chemical to mechanical, or is it just like sort of like it's not correlating with what I studied before and now, because it's quite different. I just want to know your opinion on it.
Yep. Okay, so sorry, I'm just checking my son. Okay. My opinion on that is basically you have the fundamentals of chemical engineering already when you were doing your diploma, and now you're doing your mechanical degree. which I think is a wonderful journey, because if you ask me, that's pretty much the same as what I mentioned just now, like transitioning from a process engineer to a mechanical engineer. So if you're going into, let's say if you want to work in a process plant, right? I mean, that's basically this course is about. If you have the understanding of the process first, and then you're working in, say, a mechanical maintenance, I think you have a head start between your colleagues who were doing just mechanical, because you understand, the process. Say, for example, you have a problem with this type of corrosion with this, say, compressor or pump, right? That's very mechanical. Now, if you understand the process of it, okay, the process stream of it contains, so the hydrocarbon contains sulfur, right? And sulfur, the function of sulfur can actually corrode the pump or the compressors. So that gives you a better head start than the rest who just try to figure out, oh, actually, we have to look into the process stream, and the process stream contains hydrocarbon and sulfur. Does that make sense? I think that's pretty much like my take on it. I mean, as I mentioned, I was a process engineer, and then I am currently doing mechanical reliability. So there was one time when a customer gave me a photos of a boiler, inside the boiler. There was a photo of like a white segment inside it. And they were asking if it's normal or if it is it's a defect that they will have to look into further. And just by having that understanding that, from the process side, you have a chemical, you have different types of chemical that you use to treat the boiler water inside the boiler. That would give you, if they use more than what they should be using, that could cause the white segment that's inside the boiler wall. So if I were just, if I didn't have the understanding of the process or chemical engineering behind it, probably take a little bit of more time to, to cross-check with my my other partners who had that same knowledge about it. Does that answer your question?
Yeah, thank you.
Alright, kita boleh open lagi 2 soalan Boleh?
Boleh.
Okay. So next. Siapa lagi nak tanya soalan?
Take nama, Dr. Take nama.
Cepat-cepat, saya volunteer kan dah besar masing-masing. Come on. Tulis dekat chat. Girls. You?
Ada.
Apa lagi? Okay lah, kita tanya untuk perempuan macam mana? Ada tak yang engineer perempuan, macam mana diorang punya working life? Macam susah tak? Sebab ni kan man dominated. So how about the girls? The women over there, macam mana? Dia dapat less kerja ke? Ke apa? Kalau dekat platform tu macam mana ke? Cuba cerita sikit, Chazrul.
Okay, so my experience with Petronas, definitely there are a lot of girls engineers, but luckily in Malaysia, I don't know if I use the word luckily correctly in this situation, but luckily, well, just hold on to that thought, that luckily word. But luckily in Malaysia, with Petronas, you have many girls engineers doing different sort of things. But for shift punya nature, contoh macam shift engineer, they don't give to girls because, you know, it can be quite challenging in terms of like, you know, most of your operators or all of your operators are males, right? It will be difficult for girls to be in shift because you need to change, you know, you need to be, you know, all of the sensitive issues lah, like, you know, we also want to avoid the sexual harassment when you are the only girl at site. But other than that, like for process engineer working from 8 to 5, or like from, I think Puan Razin also is working, like was also working as a with Halliburton
Yes.
in platform. So I think in that sense, in that situation, I think there's no monopoly, I would say, in Malaysia, or even in the US. When I was in the US, even there was a shift engineer, the girls shift engineer over there, just because over there I think it's not very complicated lah. I mean, they, you know, their involvement at site is not that very sensitive than in Malaysia lah. But other than that, I would say in Malaysia, I would say no different. Like as long as you want to be an engineer, you can be an engineer.
Alright, and then kena bear in mind juga untuk Encik Azrul dia kerja sebagai operator. I mean operator punya company. For mine, previously sebagai contractor. So it banyaklah huge different untuk operator ni orang kaya. So contractor ni kita buat kerja untuk operator. So the treatment, the facilities, taklah facility, I mean lagi selesa lah kalau you guys aim for operator punya company Kalau operator company ni paling senang nak cerita yang ada stesen minyak lah. So go for that company kalau boleh aim higher. So for mine sebab at first my previously my target nak masuk contractor sebab nak belajar all those technical things lagi mendalam lah kononnya, but somehow career path I dah bertukar. So it depends on you guys lah, macam mana lepas graduate nak aim company apa. Kalau but for my ni lah experience, yang operator punya company ni dia lagi selesa sikit lagi Azrul compared to macam contractor ni, dia punya treatment.
I tak ada experience in, well, right now I'm a contractor, so
kan. So sebab as a contractor macam you buat rumah, contractor means you kena please you punya tuan rumah lah. Faham tak? Tuan rumah kata I nak result macam ni juga. So somehow you kena deliver lah. Okay, so dia different kalau you punya position tu dekat mana. So nanti bila you tengok kat LinkedIn tu, you tengok company apa yang operator, company apa yang contractor. Contractor ni banyak cabang you nak masuk. Okay. Alright, tu ada question.
Proses engineer lebih kepada maintain plan yang dah sedia tak ataupun boleh buat plan baru? Okay. Dua-dua. So proses engineer yang macam saya, I work at an established punya site. So but at the same time, ni yang maintain plan yang dah ada lah. But at the same time, there will be a new upgrade project ke, macam ada new equipment install ataupun new plant install dalam that establishment. So you're doing both, like you are maintaining the current unit processes, but also when there's time, you're also looking after a new plant, a new maybe small plant. A second one is totally you're looking into a totally new plant. Macam contoh process engineer ada juga yang buat totally like dia tengok details of design of a new plant. So you can do that. You can do process engineer at site yang maintain saja. So dua-dua boleh. Depends on what you want. So macam I was briefed that macam sepatutnya ada another industrial talk, Rahimin was also my senior colleague for Razlin, is doing the design punya for a new plant. So if you're interested into doing that, there's a door for that. If you just want to just join the existing punya plant, then you can join that. Dia sebenarnya banyak sebenarnya.
Ya, itu industrial talk tu later on lah, kita set timing untuk after mid-sem. Okay. So you have all the insight. Okay, apa benda, macam apa dia buat. Alright.
Last question, last.
Siapa lagi?
Type berapa?
Last question.
Okay, good.
Ni best student ni, Brandon.
Best participant.
Yeah, okay, right. What sorts of a common knowledge you need to have, or a expectation you need to have as a fresh graduate getting into, or I don't know, anything, any field like field engineer or any source of field. What is source of, or somebody to talk to, like when you get to a new job, you need somebody to talk to. Who you should go with, who you should go for, like maybe a manager or maybe someone below your rank or anything.
Yep.
Okay.
Okay. All right. That's a good question. Brandon can speak Malay kan?
Boleh.
Okay. Sebab I teringat satu benda yang my first boss said to me bila masuk as an engineer. I was very green, I was very fresh at that time. Dia cakap, technical is number 2. I mean, as an engineer, technical is number 2. But the first thing that you need to be master of, is the relationship that you have with your team. So as a process engineer or as a mechanical engineer, you need to be able to communicate very, very nicely with your orang bawah you, operators, because they are the ones who are doing the hard work, right? You are giving them the orders. So let's say ada valve kena tutup. Valve tu dah lah 12 inch kan, macam like it's requiring like somebody's punya strength. And then you are a new engineer and then you go and ask, boleh tak tutup that, boleh tak isolate that valve? Do you think in our culture, especially in Malaysia, they would straight away want to listen to you? I mean, they would lah, because your title is engineer, but they will give you a hard time later lah. So that's why I always remind myself that wherever that I go, I will have to be very nice to orang bawah, and also especially and then your orang atas lah. So when you are talking about mentoring, definitely there will be a senior engineers that you can talk to. So of course, when you have questions about any problems, first point of contact should be your senior engineer lah, or your colleague. If tak, then you go to your manager. But I would say the most important thing, like working in a site, working at site, is your orang bawah you lah. You have to make a very good relationship with them, because at the end of the day, you're working with them on daily basis, not your manager. Your manager is just like, okay, I want this. But as long as you work very closely and very nicely with your orang bawah, then you can get the job done lah. But other than that, yeah, talk to maybe mentor outside of your site also. Macam if you have any personal, macam I have my pakcik who is NIR on steam generation, so I talk to him frequently about it. But other than that, yeah, orang atas, orang bawah semua lah. You have to be very, very, very nice.
Thank you.
Okay,
No
so
problem.
tu soalan terakhir ke? Ada lagi last soalan kalau nak? Anything yang rasa inilah masanya nak tanya Okay, sampai semua. So penat agaknya puasa dia.
Semua nak nap lah.
Dah tak ada, tak tahulah ada ke tak ada. Okay, but anyway. Dapat je lah. Tadi soalan Brandon tadi terjawab macam kena, maksudnya kita kena berbaik dengan not only your bosses tapi kena yang dekat, bukan not only your superior juga, and then kena yang orang bawahan jugalah. And then the way you communicate tu pun it's a very important thing yang you kena bear in mind lah. Cara nak bercakap dengan orang bawahan lain dengan cara orang nak bercakap dengan orang atas pun lain. Alright, kalau orang kena selalu belanja makan ke, macam tu lah cara-caranya. Itu bukannya kita kata kita merasuah ke apa, itu bukan. Itu maksudnya kita nak bagi orang senang. Macam okay, budak ni yang selalu belanja makan, aku tolonglah. Itu contohnya lah. Okay. Alright, so ada lagi soalan? Sesiapa ni last minute punya soalan? Kalau tak ada, kita boleh close lah question time punya section.
Okay.
Alright. Ada tak? Okay, 1, 2, 3. Okay, tak ada. Tapi kita pun dah banyak soalan tu, and then memang padat dia punya penerangan daripada Encik Azrul dan juga soalan-soalannya. Jadi kita punya mission untuk memperkenalkan macam mana kita nak kata mengurangkan gap dengan industri dan juga kita punya education melalui cara salah satunya inilah kita ada industrial talk di mana student boleh memahami apa yang dibuat job scope. Kadang-kadang kita tengok dekat LinkedIn ke, kita tengok dekat job street ke, kita tak tahu proses engineer ni dia buat apa sebenarnya. Macam tak faham, pening. Macam reliability engineer buat apa, maintenance ni dia buat apa bezanya. Habis aku dah graduate mechanical ni, aku boleh apply apa? Mechanical engineer je ke kita boleh so that those question inilah masanya untuk kita itulah kita mencari jawapan all those questions. Okay, sebab kadang-kadang kita Google pun kita pun pening juga. Orang dia cakap lain, orang dia cakap lain. Okay, so okay.
So just want to add one thing. So kalau ada lagi soalan apa-apa boleh je email. I put my email on the chat box. Kalau ada apa-apa soalan yang nak tanya, just send.
Okay. So itu email boleh simpan baik-baik. Okay. Nanti kalau tiba-tiba 2 tahun kemudian awak nak pergi interview, Cik Azrul macam mana ni saya nak prepare interview? You
boleh.
can always ask him or ask ni lah, all the lecturer ni korang rasa boring pula kan? So tanyalah dekat orang industri. Okay ke nanti masa nak intern ke boleh tanya, boleh tak saya nak intern? So this is one of the way. Okay. So one of the way kenalah juga memperlihatkan diri bukannya, faham tak? Okay. Kalau dulu kita orang masa belajar dulu ada satu session yang kita kena pergi high tea ingat tak? High tea ke yang wine punya minum. Jadi kita orang ni Muslim kan, jadi macam nak join macam mana, kena bayar tiket berapa puluh $. Lepas tu nak kena, kalau masuk dah tak boleh taste wine pun, wine tu yang mahal kan. Boleh makan cheese macam lepas tu being Malaysian lah, kita orang macam takutnya nak cakap macam semua Mak Saleh tu actually diorang just bercakap-cakap dengan semua the key player dekat company-company yang dekat Australia tu. Diorang datang minum-minum wine macam mingle around with all the student yang 4th year, 3rd year. So opportunity. So korang punya opportunity inilah. Kita tak ada wine tasting ke apa benda-benda tu. Jadi inilah caranya untuk ni salah seorang kita jumpa dekat industri punya person. Okay? Alright. Nanti kita cuba lagi lah. Kita akan buat session lain. Kalau insyaAllah kalau ada Encik Azrul free ke, nanti kita buat next session. Kita cakap pasal benda lain pula ke ataupun orang-orang lain ke pula Okay. Anything before we close the ni lah. Encik Azrul?
Tak ada. All the best in your studies. All the best lah sebab I dulu first year, second year I flunk je. And then 3rd year, 4th year baru ada kesedaran that I need to keep my grades above certain pointers lah. So not flunk tu as in not like fail lah, but not really like get distinction or just pass lah. So good luck in your studies and hopefully kalau ada apa-apa soalan just tanya je. Okay.
Alright, okay. Kita print screen kejap. Okay, semua buka kamera. Saya nak print screen sekejap.